Hello, my dears. This is week 3 in module 1. We will continue discussing the error during measurement. And this week we will talk about static characteristics of instruments. Let us start by precision and the definition of a precision. Precision does not have a relation with accuracy. Precise does not mean accurate. The precision means how close the measured data to each other, regardless of whether they are accurate or not. To understand this better, let us look at this dartboard here. When you look at the data in the first one, here you will find the data are close to each other, but they are far from the center. They are not in the center here. That means we call this one, the data is precise, but not accurate. Precise because they are close to each other, not accurate because they are not in the center. When I look at the second one, look here, you will find the data is close to the center, means they are accurate somehow, but they are far from each other. They are not coming on the same point. So we call this kind of data is accurate, but not precise. Precision is low. Let us look at this case. In this case, look at the data. You will find the data is spreading everywhere in the dartboard, and they are far from the center. Here we call the precision is low and the accuracy is low. The data is not precise and not accurate. When you look at this one, the last one, here, you will find that the data are close to each other and the data coming to the center. Of course, the center is our target. So if we are hitting our target, all the points coming in the center to our target, we will call the data is accurate. And since all data are coming close to each other, we call them precise. So that's how we can differentiate between precision and accuracy. So precision, a measure of consistency or repeatability of measurements. So how consistent and repeatable is how are we getting the same data, or if our data is close to each other means they are precise. By calculation, we can calculate the precision from the given equation here. So the precision is calculated as 1 minus the absolute value of yn minus ym dash over ym dash, where yn is the value of the nth measurement, means the value which we need to calculate its precision. So when I want to calculate the precision, I'm having a few values. Any of the values I can calculate its precision. So it's to be calculated per value, where ym prime is the average of the set of measurement. To understand this better, let us see the example in the next slide. Let us look at this example. In this example, we are measuring and recording the data. As you see here, we measure 10 times, and each time we are getting the measurement value. And he required the precision of the sixth value, means the precision of this value. So remember, the value which we need to find its precision is this one. So we need to calculate the average. We will see in the next slide. Here we are calculating the average of data. It's the total over the number of data. So we find that it's 100.5. And now we can substitute to get the precision. Keep in your mind that this is the absolute value. Don't forget it. So it's your answer always less than 1, or always your answer less than 1. So 100 minus 105 over 105. The answer here will be negative and negative. The absolute will remove the negative. So it's going to be 1 minus certain value, which result in 0.995. So this is the precision of the sixth data number 6. As you see, it's the 100, only this value. In the statistical analysis of measurement data, we need to do some statistics to evaluate the uncertainty of the measured data. Since we are having a range of measurement, that means we need to calculate, or we need to express the value as certain quantity plus minus the uncertainty. So how to evaluate the uncertainty? For that, we will do the statistical analysis of the measurement data. What kind of calculation we will evaluate here? We will calculate the precision, which already calculated, then the arithmetic mean or average, the deviation, average deviation, and standard deviation. These are the elements which will help us to figure out our data, or to filter sometimes our data. Like precision is used to filter the data, but the other elements are used to evaluate the uncertainty of the data. As we agreed earlier, to get the data with minimum error, we need to repeat the measurement for many times. So if I am repeating the same measurement for many times, I'm going to collect many data for one specific measurement. For that, we need to calculate the arithmetic mean or average to help us to evaluate the exact value. Of course, we are not going to find the exact value, but the value which as close as possible to the true value. If you remember, by definition, which we mentioned earlier, we said the true value is the value which evaluated by finding the average of infinite number of measurements. So here, for that, we need to know how to get that value, which is the average. So we are going to get the average of the data measured to be considered as the true value. To get the average, I think this is something very simple. Even we used it in the previous example. It's the summation of the data measured over the number of data. That's how we can calculate the average of the data. So it's given as x prime equal to x1 plus x2 plus x3 till xn, where n is the number of data, divided by n, which equal to the summation of xi until n, for I equal to 1 until n, where n is the number of measured, the number of reading, and xn is the nth reading taken, where xi is set of number, means x1, x2, x3 until xn. Earlier we know the meaning of uncertainty. Here we need to evaluate it, or we need to find a way to evaluate it. So the simplest way of finding the uncertainty is getting the actual data, the actual value, or what you say true value, and how far the highest value and the smallest value from it. Now, if I want to put example on this, very simple example, if we are measuring certain parameter, and I found that the measurement giving me a result of, I'm repeating the same measurement, I find that it's 18, 19, 20, 21, and 22. If these are the data I am obtaining during my measurement. So to evaluate the uncertainty, we will calculate the mean of the data. Then from the mean, we will check how far, the mean will be 20 here. So how far is the smallest value from the 20, and how far the highest value from a 20? That's going to be the uncertainty of the measured data. We will see this in the example of the next slide. Let us put formula first of all. The formula to evaluate the uncertainty is delta x prime is equal to x plus minus x minus over 2, where delta x prime is the uncertainty, x plus is the highest value of the data, and x minus is the lowest value of the data. Here is the example which will teach us on how to calculate the uncertainty. The example is saying we are having a measurement of these data. These are the measurement we are obtaining. So we need to calculate, and it's a time in second. He's asking me to calculate the mean with uncertainty. Keep in your mind here, the mean is considered as the true value. The mean is considered as the true value. Here, this data is a repetition of the measurement for the same quantity, the same data. So to get the true value, I mean, which one is correct? Is it this one or this one or this one or no? The true value will be the average of them. But we need to express the different in data. How to express the different in the data? It's going to be considered with the uncertainty. That's why we calculate the true value with uncertainty. The true value is the mean value, as we explained earlier, and the uncertainty is to be calculated as given in the equation of the previous slide. So first of all, we calculate the mean. The mean is found to be 1.107 second. Then we calculate delta x prime, which the change in the uncertainty is going to be x plus, the highest value is 1.18, minus x minus, the smallest value is 1.02 divided by 2 equal to 0.08. What does it mean? It means the true value will be considered as this value, but plus minus 0.08. Deviation is the difference between each piece of data and the arithmetic mean. So here we are going to evaluate for each piece of data, I mean each data. How far is the data from the mean is considered as the deviation. So the deviation is to be considered, as you see here, it's equal to xn minus x prime, where xn is the data of, data of measurement, one of the data in measurement, and x prime is the mean. And the algebraic sum of deviation is going to be considered d total equal to d1 plus d2 plus d3. It's always supposed to be 0. Always the total of deviation equal to 0. The average of deviation is to find the total of each deviation divided by the number of deviations, as you see here. This is going to help us to figure out our data in better way. So if D found to be high value, that means the precision is low, our data is not precise. And if D found to be low value, by calculation it's low value, that means the precision is high. So the lower or the smaller the value of D, the smaller the value of D, the higher the precision of the data collected. Standard deviation is a measure of the amount of variation of set of values. So low standard deviation means the data is close to the mean. The data we are collecting is close to the mean. And high standard deviation means the spread of data is wide. The data is far from each other. It's, again, we can relate it to precision as explained in the previous slide. Standard deviation can be calculated using the formula given here. This is the formula to calculate the standard deviation, where x is the measured value, x prime is the mean of the data, d is the deviation because this value here is expressed as d. We show it in the previous slides. D is the deviation, and sigma is the standard deviation.